We want to run through a checklist as you get ready for the M1 exam, paper 4 of the CIE exams, okay, 9709/4. So a quick checklist on some of the things that you need to have smack with you as you go for the exam. First, please don't make mistakes resolving forces. Yeah, we're going to talk about resolving forces. So just remember that if you are given a force, let's say 8 Newton, and let's say this is 20 degrees, so just remember that your component in the x direction, let's call it Fx, will be 8 cos 20, and the component in the y direction will be 8 sin 20. Okay, we want to go straight and settle the components without doing too much thinking. Yeah? So if I give you 8 Newton and I give you 20 degrees like this, the horizontal component F sub x will be 8 cos 20, and the vertical component will be 8 sin 20. Okay. Then please remember that when you deal with questions involving equilibrium, yeah, when you deal with equilibrium, please remember that sum of forces in any direction will be equal to 0. When you deal with equilibrium, the sum of forces in any direction will be 0, which means we can write it like this for simplicity: will be equal to 0 and summation. Okay, so it's easy to talk in terms of x direction and y direction. Yeah, so the sum of forces in the x direction, sigma fx will be 0, and the sum of forces in the y direction, sigma fy will be 0. That's when we deal with equilibrium. So the other thing is, if we are looking at a situation which is not in equilibrium, yeah? When you have a system of forces not in equilibrium, then you're going to have a resultant. Okay, we're going to have a result. Let's just call our resultant R. So draw a simple vector diagram. Okay, I'll have Fx, okay, the sum of forces in the x direction, and then from the end draw your Fy, the sum of forces in the y direction. Okay, so just draw your Fx. This is not to scale, this is just for us to get an idea. Okay, so we have Fx, and then from the end draw your Fy, and then join these two ends, and we have our resultant. So the magnitude of the resultant you can easily find, okay, by taking this squared, add it up to this squared, take the square root, you're done. And you can also find this angle here. Okay, tangent theta is just your Fy over Fx. So you can get the magnitude of the resultant and the direction quite easily from this right angle triangle. Okay, so very important for us for our exam. The next point I want to make, okay, I've made some comments here. We want to talk about work done. Yeah, please be careful about these things. Work done. Work done is given by a formula in our textbook is F times D. Some textbooks use F times S, that doesn't matter. But you have to know that this F and this D, they are measured in the same direction. Yeah? Measured in the same direction. So what does that mean? So let's do an example. If I have 8 Newton and let's say I have 20 degrees, okay, you have an object and you exert a force of 8 Newton, let's say you tie a string to it and you pull it along at an angle of 20 degrees, and let's say you cover 6 meters. Okay, so now your object is here. Okay, so remember now the distance you're measuring in the horizontal direction, 6 meter, therefore we are going to find the work done, let's just call WD, will be equals to 8 cos 20, because that's your horizontal component. Okay, 8 cos 20 times 6, and we are done. Your answer will be in joules. Okay, so that's what I mean by your F and D must be in the same direction when you work out your work done. Okay, that's one thing I want to tell you. Keep those things in mind. Let's look at, okay, the third thing, right? The third thing that you need to keep in mind will be your pulley system. Okay, so let's say we have a table here, and let's say we have an object, okay, and then we have a pulley, and then we have another object here. Okay, just to make it a bit more complicated, just let's go ahead and say this table here, okay, is rough. Okay, let's say the table here is rough. Now, when you analyze systems like this, indicate your tension here, T, this will be your, let's just call this M1G, M1, mass M1, and let's just call this M2, and we're looking at T here, and we're looking at our frictional force. Okay, what is FR? FR is the frictional force. Okay, when you analyze this system, let's write it here. Okay, what's going to happen is you are going to make sure that your string is taut. Yeah? So you place your hands below this mass, and then you remove your hands. Yeah? You have to place your hands there so that the string is taut. Yeah? And then when you remove, there's going to be motion, and we'll have motion this way, acceleration. Yeah? So what we can do is we can write your equation of motion for this using Newton's second law. So we can write m1g minus t equals to m1a. Okay, in your exam a lot of this information will be given. Yeah? This is just a quick review to tell you what you need to do. Okay, when you consider this object is moving downwards, so your resultant force downwards will be m1g minus t, and that will be equals to ma, and that will be m1a. Then we come back here. So this is moving downwards, so this guy here should be moving in this direction, A. So now here we can write using F is equal to MA again. For the object on the table, we have T minus FR will be equals to M2A. Okay, so this will be two equations, and just to remind you, frictional force is given by mu R. Okay, we have mu R, and R is your normal reaction. Okay, normal reaction. In cases like this, in cases like this, R is given as mg. Yeah? So R is a normal reaction, and this is your m2g. So I just wrote the general formula for R, which is given as mg in this case. So write two equations. Okay, write two equations. T minus fr equals to m2a. They would have given you quite a bit of the information. Just solve for these things, and we are done. You may end up using constant acceleration formulas in this kind of problem, in these kinds of problems, because we're dealing with a constant acceleration here, so they can ask you to use this to work out some distances traveled and so on. Nothing for you to worry. Yeah, once you get all these things out, no problem. The other thing I want to remind you about is this was number 3. Let's label it. Yeah. So the fourth point I want to tell you is, please don't make mistakes with questions involving linear motion. You want to get full marks. Yeah, you want to get full marks with linear motion. Okay, there will be one question on linear motion where they expect you to talk about an object is moving on a straight line, and they'll give you some velocity function or something, and we're going to use things like v equals to ds dt, and we're going to use a equals to dv dt. So nothing much to say there, except please do not make mistakes. Yeah, make sure you know the terms like maximum velocity and uniform velocity, that kind of stuff. Do your integration carefully. Don't forget there may be a necessity to include a plus c when you work things out. So this one is an easy problem. Please score full marks. One more thing that I want to tell you, okay, as we maybe one or two more things. Okay, let's talk about number 5. If you are given a inclined plane, okay, if you have an object here, okay, object here, if you have, this will be, let's say its mass is m, okay, just for discussion, this will be mg, the weight. This is theta, so don't forget this will be mg sine theta. That's the component of the weight along the inclined plane, and this will be mg cos theta. Okay, and we have our normal reaction. So we'll use this. And just if you have a problem involving friction and if it's on the verge of coming down, then your frictional force will be acting upwards. Yeah? If your question in the exam says the object is about to come down, make sure you plug in your frictional force acting upwards. The only other thing that I can think of as far as questions like these are concerned will be, let's say, if they plug in a force this way, a horizontal force, P. Okay, so be careful about this. If you have a problem, I'll just tell you very quickly, just extend the force straight in. This is P, so the components will be, because this will be theta, so we have P cos theta this way and P sin theta this way. So just be a bit careful in case they ask you to apply a force to hold an object in equilibrium. So the components of this force acting upwards along the plane will be P cos theta, and perpendicular to the plane will be P sin theta. Good. One more point, yeah, I always have some things to say about energy considerations. There will be one question involving energy considerations. Don't forget, we are looking at point number 6. The gravitational potential energy will be mgh. The kinetic energy will be half mv squared. Okay, and the work done, okay, due to resistance, okay, will be your, let's say, your resistive force times your distance. Yeah, this is your resistive force. I just use R to make life a bit easier. Okay, so these things we are going to use in the question involving energy considerations. So many times you're going to have, let's say, an engine is going to be doing work. Okay, an engine is doing work. So this work, okay, when an engine does work, it's going to be seen as an increase in potential energy. It's going to be seen as an increase in kinetic energy, and some of it is going to be used to overcome, used to overcome resistive forces. So please be careful about these things. Yeah, this is an idea in physics. When an engine does work, right, you will see an increase. You see, going up a slope. Yeah, you'll have an increase in potential energy, and then there'll be some changes in kinetic energy. Yeah, there'll be some changes in kinetic energy, and there'll be some work done due to resistive force. Again, yeah, when you have a system like this, when an engine is doing work, so if you're going up a slope, then there's going to be some changes in potential energy, some changes in kinetic energy, and there'll be some work done due to overcome resistive forces. Okay.